Our next limit example is pretty straightforward. This is limit x goes to infinity of x to the second over e to the x. Direct substitution, this gives us infinity over e raised to the infinity power is infinity. Remember, that's what this means. As you recede out the x-axis, you recede up the y-axis, so this is infinity. So yes, this is infinity over infinity, which means this is a candidate for LHopitals rule. As soon as you write equals by LHopitals rule, the very next thing you write needs to be LIM, and x is going to infinity. I need the derivative. The derivative of the numerator is 2x. The derivative of the denominator is e to the x. So find the derivative, try again. Now when you substitute, look what happens. You get, when you substitute the numerator, you get infinity again. When you substitute denominator, it's still infinity. This is still infinity over infinity. What do you do if you're trying to evaluate a limit of a fraction and it goes to infinity over infinity? Well, the result, the answer is, this is what Dr. Guffey used to tell us: if you had so much fun, do it again. LHopitals rule, look, what happens, we had second power, now we have first power. And so if you apply LHopitals rule repeatedly, in this case twice, anytime you have infinity over infinity, throw LHopitals rule at it. So what do we have here? This is the limit x goes to infinity. This is still a limit because anytime you apply LHopitals rule, anytime you write equals by LHopitals rule, the next thing you write is LIM. Anytime you write equals by LHopitals rule, the next thing you write is LIM. That is standard procedure anywhere you go to work with. Anytime you apply LHopitals rule, instructors want you to write that. That way they know that you know what you're doing. All right, so what's the derivative of the numerator? The derivative of 2x is 2. The derivative of e to the x is e to the x. And now direct substitution. Now that we're actually substituting the value, you get to stop writing the LIM. Very often what students do is they stop writing the limit notation too soon. Remember, this limit is equal to that limit, and that limit is equal to this limit, and this limit is equal to this expression, or what we mean by this expression. E raised to the infinity power is infinity. And again, we mean the limit statement by this. And what this means is 2 divided by infinity, using our infinity arithmetic, is 0. So the moral of this story is, if it doesn't work, try it again. It actually did make the problem better. And you can see if this is third power, the first time through the cycle is going to become second power. The next time through the cycle becomes first power. The next time through the cycle becomes a constant. And so you can see if this is polynomial, eventually those derivatives go to 0. So use LHopitals rule. If necessary, use it twice. And if that suffices, you're good to go.